Today we'll be looking at conditional equations, contradictions, and identities. Our objectives will be to identify conditional equations, identify contradictions, and identify identities. So let's begin with conditional equations. Today we'll use the addition and multiplication properties to solve these equations. Let's begin by subtracting 2x from both sides. When we do that, we get x minus 12 is equal to negative 1. I should then add 12 to both sides, and I get x is equal to 11. Now let me stop here for just a minute and make sure we're all on the same page. When I get x is equal to 11, let me remind you, this is the one number that I could bring up here and plug in right here and plug in right here, and my equation would yield a true statement. There is one solution that would make this equation true, and it is 11. Let me say that again. There is one solution, and it is 11. Let me say this one more time to help you understand this wording. This equation is true, and I want you to hear this, on the condition that x is equal to 11. That's what makes it conditional. There is one number I can plug in that makes it true. Therefore, it is what we call conditional. Let's now look at the difference between a conditional equation and a contradiction. Well, our steps will be the same. I'll still want to add things to both sides or subtract things from both sides, and I start out doing that. So in this one, I would add 2x to both sides. When I do, all of my x's eliminate. They're gone. And I now have a line that says 1 is equal to negative 2. Well, is that a true line? The statement is not true. Is it ever true? No, it is not. As a matter of fact, it's what we call a contradiction. This line is never true. There is never a time that 1 is equal to negative 2. So there is no solution that will make this true. Let me put that in writing for you. Since 1 is not equal to negative 2, this is a contradiction. Let me point out one more time. All of your x's eliminated. You ended up with a line that was not true. That's how you identify a contradiction. Let's look now at an identity and see if we can tell the difference between it and a contradiction or a conditional equation. They look the same when you start. Let's remember our steps for doing this. We'll still distribute here, and our next line would look like this. 2x plus 6 minus 4 is equal to 2x plus 2. I see some like terms on this side. I can combine those, and I get 2x plus 2 is equal to 2x plus 2. And I want you to notice you can see it right now, or you can keep going. At this point, you have a left-hand side of the equation that is exactly identical, do you hear the word? Identical to the right-hand side of the equation. If you continued on and you subtracted 2 from both sides, and then you subtracted 2x from both sides, you would end up at a line that says 0 is equal to 0. Now let me make sure you understand. It would be perfectly okay if you stopped right here, but if it takes you going to this part to see it, that's okay. But what you should see is that the left-hand side of the equation is exactly identical to the right-hand side of the equation. When that happens, your solution is all real numbers. That means I could take any real number I want to and plug it in for this x and for this x, and I would get a true statement. I know that sounds a little far-fetched, so why don't you try plugging in a 0, for instance, and see what you get. Come back and plug in a 2 and see what you get. If both of those make it true, then it would help you to understand what an identity is. Let me remind you, you know it's an identity, once again, when all of the x's eliminate, but this time you end up with a true statement. In a contradiction, you ended up with something that looked like this, a false statement. But in an identity, you end up with a true statement. I want to leave you with my thought for the day. Let us so live that when we come to die, even the undertaker will be sorry. I was blessed enough to have a dad who lived that way. I'll see you again soon. Bye-bye.